Hello everyone, welcome back to my YouTube channel. My name is Arnav Jain and I am currently working as an SD2 at Amazon. In this video, we are going to talk about the bridge design pattern. So far in this series, we have already covered all the solid principles and we've also explored a few creational design patterns like factory method, abstract factory, and the gang of four factory pattern. In the structural design patterns category, in the last video, we covered the adapter design pattern. Now today, we are going to understand one of the most important structural design patterns, the bridge design pattern. Before we move forward, if you haven't subscribed to the channel yet or liked the videos, please consider doing that. It really motivates me to create more content like this. Alright, let's get started. To understand the bridge design pattern, we'll begin with a simple problem statement, and then we'll gradually evolve it into a better design. So imagine you are building a file processing and storage system. In this system, you can have multiple types of files, for example, images, videos, and documents. At the same time, you also have multiple storage providers like AWS S3, Google Cloud Storage, and your local file system. You can choose which file should be stored in which storage. Now, here's an important constraint. You cannot store different types of files in the same bucket or location. That means images must go into a dedicated image bucket, videos must go into a dedicated video bucket, documents must go into a dedicated document bucket. Additionally, each file type requires specific processing before upload. Images need to be compressed and resized, videos need to be encoded, and documents need to be formatted. Now let's understand how we can implement this solution without using any design pattern and then understand the problems that we face. I have already implemented the code for this, so let me explain the code to you and the problems we are facing in it. Alright, so let's understand what's happening in this code in a simple way. We have created a common interface called file loader, which has a method called upload. Every class implements this, so no matter what type of file or storage we are using, the method name remains the same. After that, we started creating separate classes for every combination. For example, if it's an image and we want to upload it to S3, we created image S3 uploader. Inside this class, we first perform image-specific operations like compressing and resizing, and then upload it to the S3 image bucket. Then we did the same thing for Google Cloud and local storage. Again, compressing and resizing the image and then uploading it to a different storage. After that, we repeated the same pattern for videos. But instead of compressing and resizing, here we are encoding the video and then uploading it. Then again for documents, we are formatting the document and then uploading it. So basically, for every combination of file type and storage, we created a separate class. Now if you look at the main method, we are simply creating objects of these classes and calling the upload method. If we execute the code, we are getting the expected output. So from a functionality point of view, everything works fine. But the real problem is in the design. We have 3 file types and 3 storage systems, which already gives us 9 classes. If tomorrow a new file type comes or a new storage system is added, the number of classes will keep increasing. Also, if you notice carefully, we are mixing two different things in the same class. One is file-specific logic, like compressing an image or encoding a video, and the other is storage logic, like uploading to S3 or Google Cloud. Because of this, the code becomes tightly coupled, repetitive, and hard to maintain. So the problem is not that the code doesn't work. The problem is that this design is not scalable. Now the question is, how can we separate these two things and make the system flexible? That's where the bridge design pattern comes in. Alright, so I have implemented the code using the bridge design pattern. Now let's understand how this actually works in a very simple way. At the top, we have something called storage. This is just an interface and it defines one thing: how a file will be uploaded. We don't care whether the file is going to S3, Google Cloud, or local storage. All we say is every storage should know how to upload a file. Then we create different implementations like S3 storage, Google Cloud storage, and local storage. Each one has its own way of uploading, but they all follow the same method. So these classes handle how the file is stored. Now let's move to the file class. This is an abstract class and it represents what kind of file we are dealing with, like image, video, or document. Inside this file class, we have a reference to storage. This is the most important part of the design. Instead of deciding storage inside the file, we pass the storage from outside using the constructor. So the file and storage are not tightly connected anymore. This is exactly where the bridge exists. Think of it like this. On one side, we have file types like image, video, and document. On the other side, we have storage systems like S3, Google Cloud, and local. These are two completely separate dimensions. The bridge is the connection between them, which is created using this reference to storage. So when we write something like new image file with S3 storage, we are connecting image to S3 using that reference. That connection is the bridge. It is not a separate class, it is simply the relationship between the two. Now coming back to the file class, we have a method called process and upload. This defines a fixed flow. First, the file is processed and then it is uploaded. Every file follows this same flow, but the processing logic is different. Then we have specific file types like image file, video file, and document file. Each of them defines how the file is processed, what the file name is, and which folder it belongs to. So each class focuses only on its own responsibility. Finally, in the main method, we create storage objects like S3 and Google Cloud. Then we create file objects and pass the storage into them. This is where the connection happens at runtime. When we call process and upload, the file first processes itself and then it delegates the upload to the storage. So both responsibilities are clearly separated. Now let's understand why this design is powerful. If we had not used the bridge design pattern, we would have needed to create a separate class for every combination of file type and storage type. So if we have n file types and m storage types, the total number of classes would be n multiplied by m. But with this design, we have separated file types and storage types into two independent hierarchies. So now we only have n file classes and m storage classes. The total number of classes becomes n plus m instead of n multiplied by m. And that is a huge improvement in scalability because we can now add new file types or new storage systems independently without affecting the existing code. That is why the bridge design pattern is so useful. Now let's understand the class diagram. At the top, you have the bridge pattern demo class, which is your main class. This is the client of the system. Its job is to create objects and decide which file type should be used with which storage. Then you have the storage interface. This represents the storage side of the system. It simply defines one capability, uploading a file. It does not care whether the file is going to S3, Google Cloud, or local storage. After that, you have concrete implementations of this interface: S3 storage, Google Cloud storage, and local storage. Each of these provides its own implementation of the upload method, but from the outside, they all follow the same contract. Now, on the other side, you have the file abstraction. This is an abstract class that represents a file in general. The important thing here is that it contains a reference to storage. This means every file object is connected to a storage object. This connection is what we call the bridge. The file class defines the overall flow. It says that before uploading, the file should be processed and then it should be uploaded using the storage. But it does not define how the processing happens. That responsibility is left to its subclasses. Then you have concrete file types: image file, video file, and document file. Each of these extends the file class and provides its own implementation of pre-processing. Images are compressed and resized, videos are encoded, and documents are formatted. They also define details like file name and folder. With this, we have completed our bridge design pattern. If you liked the video, please like and subscribe. See you in the next video.